in this video, we're just going to talk about the definition of the derivative. We're not going to do any math or go through any problems. That'll be another video. This is just to talk about what the definition of the derivative is and how we get it. And what we do is we're going to look here at the difference quotient. And we know the difference quotient is f of x plus h minus f of x over h. And we use the difference quotient. We'll look at this graph right here. It's a graph we used before in another video. We've got these 2 points. 1 point here, 1 point here. And the difference quotient tells us the slope of the secant line through those 2 points, connecting those 2 points. So what we want to do here is we have this gap h. And as we go from this graph to this graph to this graph, all we did is we took the same curve here, and we just made h smaller. We made that distance between the 2 points smaller and smaller and smaller. And the reason for that is if we want to know what's happening to a graph right over here, we can take a point here, and this does not give us a reasonable estimate of, say, the slope right here, how our graph is changing. As we get closer here, I mean, it's still not very accurate or close to the slope here, but it's definitely closer this right here than it was over here. And then as the 2 points here get even closer, we can see that this line seems almost tangent to this curve here. It kind of goes the same direction as the curve, right at this point, as the curve goes down, the line goes down. But what we want to do is, what if we could push these points even closer? And closer and closer and closer, as close as we possibly could. Now, according to the definition of our difference quotient, we cannot make these 2 points have no space between them. We cannot have just a single point here, because the space between the points is h. And if that goes to 0, we're dividing by 0 in a fraction, and we can't do that. But with the little bit of limit work here, we are able to almost divide by 0. So we talk about the derivative, which is going to be the slope of the tangent line. This is going to be the slope of the tangent line to f of x. It's exactly like the difference quotient, this piece of it is, but instead we have a limit in the front. So we're going to say it's the limit as h approaches 0 of f of x plus h minus f of x all over h. So what we're doing is we're making this h here, which was the gap between the 2 points on the graph, we're making that essentially so those points are on top of each other and that there's no space between them, so we're looking at the tangent line to the curve. Instead of the secant line between the 2 points, we're looking at the tangent line at a single point.